welcome to newest science practical lessons. Today we will look at moments. The aim of this practical is to calculate moments, to describe how they apply in real life, and in terms of our scientific skills, we will inquire and analyze by recording our data, and we're analyzing the data and we will draw some conclusion from our data. I'd like to mention something about the safety. I have here a stand. I'll have to be careful how much I pull this stand, and I will have to be careful on standing aside the stand to avoid it to drop on my feet, which is not going to be really nice. Okay, what do I have here? I have a typical lab stand that you've seen probably in every science lab at NUEST, and I attached various elastic bands, okay, simple elastic bands at different distances on the stand. Then I have this piece of equipment here, which I'm going to show you in more detail. As you can see here, you should recognize this piece of equipment. It is a Newton meter, so we're going to measure newtons from it, and we're going to measure force in newtons. Okay, we're going to take a measurement and then we're going to repeat the same measurement 3 times. Why do we do this? I mean, it's a bit of waste of time doing it, isn't it? I could have done something different, in the meantime. Well, it's very important to actually repeat the measurements, and I'm using this word, specific word, repeat. Okay, if all my 3 measurements will be close together, we can say that the measurements are repeatable. These words might not be confused with reproducible, which is instead if someone else, some other science teacher, would redo this experiment and get the same results as I did. So repeatable is me repeating the experiment using a specific method. Reproducible is someone else repeating the experiments using the same method and getting the same results. But done with the talking, we'll now get going. So I have my first mark here, which I will call position 1. And what I do, I will hook this Newton meter at my position 1, which is the closest to the bottom of the stand. This bottom is, we'll call it pivot. Okay, so it's close to pivot. You will see why I called it pivot in a second. When I pull this, what is going to happen? Well, at some point, when I exert a large enough force on it, it will start tilting my way. Okay, so that's why we call this point pivot, because it's the point where the whole object is tilting. I'm going to read what this force is, and it is 3.5 Newton. Okay, 3.5 Newton. If you remember, we talked about introducing errors, and the reason why I actually try to look at this Newton meter perpendicularly to the scale, so at 90 degrees to the scale, is so that I can reduce an error called parallax error. Okay, I'm gonna go and record this in our table as first reading. This is my first point, and the first reading was 3.5 newtons. I don't have to put another n here because I already have it here in my table. Now, instead of repeating the experiment 3 times in a row, I will actually take all the measurements first and then repeat them all a first time and a second time. And then I will calculate the mean. Then we'll see how to calculate the moment of a force. Okay, so position number 2. Okay, I need to hook this again. Note that I'm using the same Newton meter. I'm not changing anything else. What I'm changing is just the position of this elastic bands on the stand. Okay, again. Now, before I actually do this, I would like you to think and make a prediction, which is based on your prior knowledge or you know, an educated guess that you can have. Is it going to require more or less force to tilt this if I'm further away from the pivot? Just have a guess, think about it, just keep it in the back of your head. Okay, right, if I read here correctly, this time, again I'm trying to get perpendicular to it. This time is 2.5 newtons. Okay. So, is your prediction confirming what we are looking at or not? Is it actually enough just to have 2 points to check if your prediction is correct? All these are good scientific questions. Okay. Third place, and I have 2 newtons this time. Okay. And then here. Here we go. Okay. Let's see. What do you think I got this time? You can think about it, pause, and then see if you were right. Okay, wait a minute. So we got 3.5, 2.5, 2.0, 1.5. Let's see how repeatable these are. Okay, this is 3.7. And then the second one. Okay. 2.4. Let's see here. 1.8. The one at the top. Okay, 1.3. And guess what? We're going again. Third reading. All right. Let's see. This time I got 3.4. Okay, then I'm repeating the second one, and 2.3. Okay, one here. We got 2 again. And the last but not the least, here we have 1.4. Okay. All right, so let's calculate some means now. Okay, so you can get your calculator out and you can use it to calculate the mean. I want you to pause this video, try to do it yourself and calculate the mean here and then see if you got the right results. Okay, we're back. So calculate the mean. The first one should be 3.5. The second one, what I have to do is 2.5 plus 2.4 plus 2.3 divided by 3, which is giving me 2.4. The third one is going to be 2.0 plus 1.8 plus 2 again, divided by 3. Oh, this time I have 1.933333. Well, how many numbers do I need actually here? As you can see, all of them have just one number after as a decimal in the first decimal place. So I can just round this number to the right amount of figures, and it's because it's not 1.93333, I can just write 1.9. The last one, okay, I can do it in my head really, the last one, because I don't really need to calculate it, okay, but if you want to do it, you need to do 1.5 plus 1.3 plus 1.4 divided by 3, and that should give you 1.4. Okay, I would say if we look at these sets of results, they are quite repeatable, they are quite close together, okay? So remember the difference between repeatable and reproducible. Repeatable if I repeat it, reproducible if someone else is repeating using the same method. But what conclusion can we make from here? Okay? Because there's actually something that is not working quite well. Now, this one seems to be almost 0.5 in difference. Well, this one here seems to be 1 in difference between the first point and the second point. Okay, let me go back to my experiment and see what I actually done. Alright, let's measure the spacing in between this and the spacing between the pivot and the first point. And let's see if we actually calculate it properly. Alright, in between these two, I have 0.1 meters, which is alright, so let's see if we calculate it properly in between the elastic and in between this elastic here and the pivot. Alright, okay, this is 10 centimeters, so it is correct. 10 centimeters, it is correct. 10 centimeters is correct. Oh, here I have 20 centimeters. That's why I didn't fit the pattern really well. Okay? So if something doesn't quite fit the pattern, you can just go back to your experiment and understand where you went wrong and understand your experiment by analyzing your data. But let's go back to our results. So this distance here is no longer 0.1, okay? It is actually 0.2. 2. But this one is still 0.3. This one is 0.4 and this one is going to be 0.5. Okay, so I changed it a little bit. Okay, so if we calculate the moment as force times distance, then I will have to do 0.2 times 3.5, and that will give me my moment, which is in newtons meter. Newtons for force times meters for distance. Okay, so we made amend for our mistake, and now we can go and calculate the moment. I'm going to leave you this to do by yourself and see what you get. But as you can see, it seems that there's a need of less and less force as further away we go from the pivot. Okay, so this is what my observation. Let's see if you can come up with different observations by analyzing this data. Okay, so today we talked about moments. We calculate how much force is needed to tilt this stand depending on how far away from the pivot we are. We analyzed the data. We realized that they didn't quite fit the pattern, and we actually went back and changed some of the initial data that we put in the table based on our analysis. We talked about reproducibility and repeatability and what they mean. I hope you enjoyed. I'm Dr Maniscalco, and I'll see you soon in another newest science practical lesson. Bye bye.